We are going to begin looking at motion problems with calculus, and for right now we're going to look at equations or algebraically. Let's go ahead and take a look at example 1. It says the height of a helicopter in feet is given by the following equation. S of t, which normally denotes position, don't know why we use S of t, but we do, is equal to 600t minus 2t cubed after t minutes. So what this means for the helicopter is that after 0 minutes, it's going to be 600 times 0 minus 0 would be 0 feet high. After 1 minute, if we plugged in 1 for t, we're going to get 598 feet. After 2, we'd get a different number back, so on and so forth. So if you plug in after so many minutes, it's going to tell you how high the helicopter is. So we're going to start with an easy question for this first example. It says, how high is the helicopter after 3 minutes? So to figure out how high it is after 3 minutes, this is simple because all we have to do is plug in 3 into the position equation. I would say in this case the key word is how high. That involves position. Later on we'll look at speed and those kinds of things. So I'm going to go through some steps for these problems. The simple ones, you can breeze through the steps. These are more for more complicated motion problems, which we will indeed encounter. So what you want to do is write out which is given algebraically. So in this case, we're given this equation. I'm going to go ahead and write it out. So now that we've written our position equation out, let's go ahead and go to the next step. The next step is to convert what is given verbally to algebraic expressions. If we go back and read the sentence again, notice that I underlined how high. And it also says, is the helicopter after 3 minutes? So the other thing I want to underline is 3 minutes. We're going to take these two expressions and convert them to algebraic expressions. So how high after 3 minutes is going to be S of 3. I'm just going to write equals question mark, right? Now, since we know that time is 3 minutes, we're going to write t equals 3. So again, this is a simple example, but this step is useful, especially when these get more complicated. Step 3 is going to be convert the verbally stated question into an algebraic expression. So I kind of already did that actually here. Should have done it down for step 3. Jumped the gun a little bit, but we want to figure out what S of 3 is. And we were given that t is equal to 3. So you can pretty much see by now that we're just going to be plugging in t is equal to 3. Okay, the next step, again, this is a simple example. We want to start simple and increase in difficulty. Step 4 is to map out the relationship between position, velocity, and acceleration. Now, you might be thinking, okay, well, is it really necessary? Yes, it is. And the more you map out these relationships, the more successful you're going to be with position and motion problems. So let's take a look at that map. So I went ahead and did this in purple. We have, first of all, position equation. The next equation down is velocity, and the next equation is acceleration. Now, here's how they relate in terms of the derivative, and this is why we're going to map it out. Because when you take the derivative of position, you get s prime of t, which is the same as the velocity, v of t. So you want to notate that because it makes sense that the rate in which the position is changing is the same as velocity. And this map is going to help you again with more advanced problems. And then finally we have acceleration, which is the second derivative of position. It makes sense because it is the rate in which the velocity is changing. So if you wanted to, you could write v prime of t equals a of t, which is the same as the second derivative of position. The more you understand this map, the more success we're going to have in these questions, because eventually you're going to have to move backwards, and this map will help you. Okay, so step 5 is to solve the problem using either initial value or derivative procedures. Now in this case, it's a very simple one. All you have to use is the original initial equation. So we're trying to figure out S of 3, so let's go ahead and so again, looking at step 2, we want to figure out S of 3. Step 1, we have the equation we need, so we're just going to replace t with 3 and solve. Okay, so here's S of 3 equals 603 minus 2t cubed. So when we do the math, 600 times 3 is 1800. 3 cubed is 27 times 2 is 54. 1800 minus 54 is 1746. This leads us to the last step, which is to answer verbally. So what does that 1746 mean? So my final answer is going to be the helicopter is 1746 feet high after 3 minutes of taking off. So suppose this green circle is the helicopter. It takes off, and after 3 minutes, it's reached 1746 feet up in the air. And eventually, like, this helicopter is going to come back down, right? So we will look at some more problems. But a lot of people that take calculus need to understand that if you're going to be an engineer of something, you need to be able to communicate verbally with whatever answer you come up with for your company. And this is a very simple problem, but the wording helps you to understand, go back to what the question was asking. It gives you further comprehension as to what you were solving when you plugged in 3. So that's it for this example of the helicopter's position. If you have any other questions about it, let me know.